Hey everybody, welcome to another homework help video. Today we're doing the first lesson from chapter 10, which is a chapter on statistics. If you're using this video this year that we made it, we're not going to get through all of chapter 10 or a lot of it, maybe half. And we're going to just start at the beginning. The good news is the beginning of the chapter kind of includes some concepts that you might be familiar with already. So it should help you do a little bit of a better job at finishing it quickly and be a little bit more understandable because the first two lessons are kind of some introductory stuff. But I do want to show you how to answer the questions just in case you get caught up on some, okay? So the first couple of questions here ask you to look at this set of data. This one says each of 6 students reported the number of movies they saw in the past year. This is what was reported. This is how many movies 6 different people saw. It says find the median and mean of the number of movies the student saw. For those who forgot which means which, the median means if you line them up from least to greatest, which number is right in the middle. And the mean is if you add up all the numbers and divide by the amount of things you have, in this case 6 things, that gives you the average. Mean's just a fancy way of saying average, and median saying what's like the middlest amount. And they both have a good purpose. They're both useful in different times when you're doing statistics. And that wasn't really covered in the lesson video, but I did put some questions about that here a little bit later, so we're going to talk about those when we get there. First, how do you find these things? Okay, well, the median, the easiest thing to do if you're doing it on paper would be to write it down in order. So if I was doing this on paper, I'd write 5, 8, another 8, 9, 11, 14. I think those are the numbers, right? 6 of them? Yeah. Okay, the problem we have here is there is no middlest number, right? Because the way you kind of count it is you say, okay, there's one on the left, one on the right. Second one from the left, second from the right. And you should keep doing that process counting inward from both directions until you find that one in the middle. The problem is there's not one in the middle. There's 8 and 9, but there's no number between the 8 and the 9. So in that case, the median you find it by finding the average of 8 and 9, which is 8.5. The answer to the median is 8.5. I'll tell you that right now. However, I'm going to show you on Desmos how to skip all of that thinking there. Desmos has some nice statistics features that you can find on this functions menu here. And then it says stats. There's all these different options here. So if you're stuck on a question on statistics stuff, you could maybe consider looking at this and maybe it'll give you something useful. And you'll notice that there's the mean and the median. Your question might even ask you the mean first, by the way. I'll click median, and it gives you this parenthesis, and it wants you to type the set of numbers you want to find the median of. So I'll type it 9, 8, 11, 5, 14, 8. And it spits out 8.5. Notice I didn't even have to write it from least to greatest. This thing is doing that automatically behind the scenes, which is super nice, right? So there's my answer. 8.5 was the median amount of movies. Okay, now for the mean. And you'll notice it has the word mean. By the way, if you don't want to click that button every time, you really don't have to. You can literally just type the word mean and see how it goes from like italics to regular. When it goes regular, that means it's now acknowledging that you're typing in something useful rather than what it thought was 3 variables. MEA doesn't mean anything to it, but the word mean means something. Okay, then I'll type it again. 9, 8, 11. This is where, if you're doing this on a computer, it will be helpful because there's a lot of stuff you can copy and paste. Notice my mean has this crazy decimal. My problem says, if necessary, round to the nearest tenth. So 9.2 is the nearest tenth. And that's it. We're just going to type stuff into Desmos. I mean, for finding the mean and the median, that is. All right, another one. Mean, 9, 20, 15, 17, 11, 4, 8, 13. Okay, so my mean here is 12.13 because, again, it says round to the nearest tenth and it says 12.125, but I can't have the 5, so the 5 tells me to round the 2 up to a 1.3. Oh, wait, that's the nearest hundredth. Okay, fine, 12.1. That's the nearest tenth. Okay, and then for the median, now here's pro time saving tip right here. See this word mean? Just delete some of it and change it to the word median. There, the median's 12. The mean and the median, being closer together is a good thing in statistics, but I mean, honestly, when you ask just 8 people, you should never have any expectation of that. Let's say you asked 100,000 people something and the mean and the median were really close together. That's good in real life. That's a normal data set. Well, it would be an indicator of that. 10, 11, 5, 6, 7, 7. Okay, I get 7.6 repeating, so 7.7 will be the way to go. And as I said before, I'll change mean into median. Check this out. You can just add the DI and it becomes median. Pro moves. And that covers mean and median, I think. Did I put 3? No, I put 4. Okay, I'm not done yet. Let's do another one. So first I find the median. Oops, don't put any extra weird stuff. 9, 10, 20, 19, 4, 6, 15, 12. Okay, the median's 11. And then the mean, I will delete a couple letters, and there's my mean, 11.875. So 11.9 will be the mean. Those aren't actually that close together. Ta-da! Now, be careful on the next problems. Really in math, I guess, when you're doing statistics, you usually find the mean, the median, and the mode all at once. The mode is the most common number. So what you'd have to do is, all you have to do is look at this and look through and be like, okay, which number appears the most often? And that's the number, that's the mode. And it's honestly not too hard to do by hand. You can be like, okay, 4, 4, 4. There's 3 4s. There's 4 1s. That's kind of a contender. There's 4 2s also. So what do you do when you have 2 things at the most? Well, it says if there's more than one mode, write them separated by commas. So in this case, I'd write 2 and 4. Because no, 2, wait, I can't count 1 and 2. Sorry, there wasn't that many 4s. Wait, there was 4 4s. Wait a second. There's 4 4s, 4 1s, and 4 2s. Are there 3 modes? Okay, I guess you got to be careful, huh? Now here's the thing. If you go on Desmos, it doesn't have mode. Like, see, there's a math function that we don't need to worry about called mod. I think I can do 4 mod 3. Or wait, 3 mod 4 equals? Nope. I haven't used that one in a while. All right, anyways, they don't have a mode thing on Desmos here under the statistics, so I have to apologize, but you're going to have to do this one on your own here, okay? So when you're doing the mode, you're going to want to see which one is the most and write that, and if there's multiple tied for the most, you'll write as many as you need to. Hopefully not 3 things. That's silly, but whatever. I think the only exception to the rule is if every single thing in the data set appears the most times, like let's say there's 2 of everything, I don't think that should constitute having a mode. Okay, don't quote me on that. Try it. I don't know. I'm not for sure I'm going to get that. Okay, 1, 2, 3, 4 zeros. That's looking like that's it. There's only 3. No, there's 4 2s also. I'll be darned. There's not that many 3s and not that many 4s. All right, there's your mode for you. What appears the most often? Easy peasy, right? Okay, now as promised earlier, which of these things is useful when you're doing statistics? This was not in the lesson video, so if you're watching this, hope it's giving you some good info. They want you to figure out, they say the same on all of these, more or less, which measure should be used to summarize the data? Which measure gives the most common year of birth? Which measure should be used to summarize the data? They want you to think about which thing you should use, the mean, the median, or the mode. So here's how it works. The mode is the thing you want to use when you're trying to find what happens the most often. And you see the second question says which measure gives the most common year of birth? Well, that's like saying I want to know what happens the most often. So that means this one's the mode. Now that being said, there could be multiple on here that ask for the mode, but I think in my experience with Alex, they always have it so that all 3 different things get used. You should not expect that, but I think that's the case. Okay, now we look at this number set. You don't need to find the mean and the median to decide if you should use the mean and the median. I think on this first one, you should use the mean. And the reason why is this. If you look at the numbers, 196, 199, 202, all the way up to 210, they're all pretty closely grouped together. There's no wild jumps in value. I mean, 196 to 210 is a range of 14. It's not very far, right? they're all pretty clustered. But if you look at problem part C, there's 52, 53, some things in the low 60s, and then this dude that's 96 at the end. Well, here's the problem. When you have a number that's significantly different from the other numbers, the mean is now skewed, which means like it's way different than it would have been if there was no 96, right? Like, just to show you, I'm going to find the mean here of this bottom one. You don't absolutely do not have to do this on this problem, but I do want to illustrate why this is important stuff. 62, 63, 65, 96. Okay, so the average is 62. Does the average look like it should be 62? 62 is on the list. It could totally be the average. But is it most of the numbers, like low 50s to the 60s? Low 60s? So like if I take the 96 out, the average now becomes 58, which is more like what's in the middle of these actual numbers. The 96 really pushed, I mean, it didn't push it up a ton, but it definitely pushed it up, right? So in this case, it's better to use the median. Maybe you've heard the phrase median household income, like in the United States or something like that. We use the median because there's people who significantly make so much more money. Like let's say you're taking the average amount of money somebody makes, right? And they say, oh, it's 60,000, and you're like, oh, that's kind of nice. But if we added in all the people that are like millionaires and billionaires' income to those things, that would extremely inflate it and make it seem like everybody's getting way more money than they actually are. If they said the average, salary was this, you'd be like, oh, why am I so low? Well, because the millions and billions salaries are blowing it up, right? At the same time, potential salaries of zeros are also lowering that as well. So when you use the median, it kind of cancels out the outliers, the big and small numbers that are way too big and way too small to be considered normal, and then it cuts more of like a better answer. Whew, that was a large explanation. Let's apply that on a second problem. All right, with the 9 members here, which measures should be used to summarize the data? 9 members of the swim team doing laps. Okay, so we look at the lap time. So we have 24, 76, blah, 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 up to 91. Okay, look carefully. I see 90s, 80s, 70s. Okay, it's pretty nice. And then 24. Don't you think that's a significantly different number from the other ones? They're all in the 70s or above. I think 24 is a pretty big drop. So in this case, the median seems like the thing you would want to choose because we have a outlier skewing the data. On the next one here, looks similar. It's got a list of people talking about how many soft drinks they had in the last month. 28, 29, 30, 38. Okay, it's not too bad, right? Like 28 to 38 is not a large jump, and all these numbers are like in the high 20s all the way up to the 30s. Not too bad. So a mean would be good here. On a test, the student is given A, B, C, D, or F, which tells the grade given most often. Well, most often means the mode. That one should be, I hope that one's the easy one for you to select on that. All right, now we're getting into the harder questions. The mean, median, and mode are all things I feel like you just count it or you just plop it in a calculator and it's pretty easy. It's good to know when to use those though, that's very important. Now, percentiles, though, get a little bit more tricky. Now, we're not to percentiles yet. This question leading up to it is not so bad. It says, what percentage of these professors who are younger than 40? So what you would need to do is go through this list and figure out how many people are younger than 40. So no. 1, 2. So out of this whole list, there are 2 numbers on the list that are younger than 40. So what percentage is that? Well, there's 10 professors on this list. So what you do is you go to a calculator and you say 2 out of 10 was younger than 40. And now you need to convert that to a percent. The quick way to do it is just multiply by 100. 20%. 2 out of 10 is 20%. I mean, I would hope that'd be a little obvious. But hey, if it's not, that's okay. Literally, make it a fraction. This many were true. Out of this many were on the list. Times it by 100, and there you go. I'll do another one even though there's not 2 of these on here. I just want to show you kind of the process again. Okay, here are the test scores for 8 students. 8 students is important, so it's going to be something over 8. What percentage was less than 91? So we count them all up. So 68. Don't count 91. 91 is not less than 91. It didn't say less than or equal to. So 68. So there was 1, 2, 3, 4, 5, 6. 6 numbers out of 8 were less than 91. If you don't know what that as decimal is as a percent, multiply it by 100. I hope you do know. Seems pretty obvious. 75%. There you go. So that's how you find a percent of people that are lower or higher than that. Now that leads into these kinds of questions, which are percentile. So say you lined up all the people or all of something in the planet and said, okay, what's the 30th percentile? The 30th percentile means that you're better than 30% of the other results. Like, so on this list, there's a PE ratios, price of stock divided by projected earnings per share for 15 banks. Okay, numbers, right? If you were to line these numbers up, what should, oh, look, the calculator is doing something. If you were to line these numbers up, calculator, leave me alone. I don't want it. Okay, if you line these numbers up, which number is better than 30% of the other numbers? Like it's higher than 30% of the other numbers. So that's like, okay, that would take a little bit of work, right? First, you have to line them all up in order. That's very important. If you're doing this by hand, by the way, you line them up in order. There's 15 banks. You have to find what 30% of 15 is. 30% of 15 is 4.5. So you need the 4.5th item on the list, but you can't take a decimal item. Like there's not an item number 4.5. So you'd have to take the 5th item because that's rounding. Well, yeah, you probably want to round up or down to the nearest one. I think that's the process you want to do there. Whew. Now that's a lot of work, right? I believe there is let's see, is there an option on here on Desmos? I'm finding out as I'm doing it. We're gonna find out today. No, I don't see this lined up here in order there. Oh no, we don't have a percentile thing. Oh darn. Oh man. Okay, that's okay. We can still work with this. All right, you ready for this? We're gonna be doing the process now. I should probably get out my. Hold on a second. We're just gonna do a quick conversion here. First, we're gonna open Paint. Put Paint in its spot. Oh, it seemed a little wide, but it was just right. There we go. This is what I get for not pre-planning, man. Okay, that's not all the way to the edge. It's kind of bothersome to me, but I am going to live with it. Oh, wait, was I supposed to plug in the device, then open Paint, or open Paint, then plug in the device? I always forget the order. Yeah, seems to be working okay, right? Okay, good. All right, here we go. You ready for this? So, doing this the long way. If it makes you feel better, there's only 2 problems like this, and the rest of the assignment, as you probably noticed, was not severely long. And also, there's only 1 assignment this week, so it's not so bad. My advice would be this. Okay, don't do that. Okay, my advice is this. Plug in your device first, then open Paint. Otherwise, Paint gets all wacky. All right, now it should be better. Hold on, I'm writing them out. I'm not writing them in order. I'm just writing it in the order they're written here. 18, 19, 22, 29, 34. Okay, so what you'll need to do is you'll need to rewrite them in order. So what you'll have to do is look through the list. I'd say start with the smallest. So 18 is the smallest. I cross it off before I write it. Okay, and then I see a 19. I see a 20. Do I see a 21? Yes, I see it twice. I will write it twice. That is very important. If it appears more than once, write it more than once. I see a 22 twice. I'm going to use 2 lines. I was trying not to. I was trying to write small, but it's impossible. I see a 23, a 24, and a 25. Okay. Let's see. 29 appears to be the next smallest thing. Then we have 31, 34, 43, 50. 40 didn't come out so good there. We'll rewrite that. Okay, perfect. Okay, so now it's in order, right? You gotta have to put it in order. So now off to the side, completely separate from those numbers, the 30th percentile means this. 30%. You need to find 30%. Wait, the 30th percentile. Oh, yeah, that means, okay, so it's this. So you find 30% of 15, basically. So 30% of 15. Why am I finding 30? Wait, hold on. Looks a little gross. Why am I finding 30% of 15? Because there was 15 items on the list, and we need to know which item is 30% down the list. So you need to get a calculator out or something. It's 0.3 times 15. Calculator would say that's 4.5. Now the problem is that's not a whole number. I can't go over 1, 2, 3, 4.5, right? So what that means is you'll need to round to the next highest or lowest. The good news for us is 4.5 falls right here between 21 and 21. So the 30th percentile would be 21. Okay, then we do it again for the 75th percentile. So I find 75% of 15, and 75, and that's 0.75 times 15. And I'm pretty sure that that's a number that I don't want to bother finding. It's not too hard, but this time I'll use a calculator. Might as well see how it's done, right? 11.25. Uh-oh, I have the potential to be wrong here. Hey, and if it's wrong, it's wrong. You know what I mean? Let me write that down. 11.25. Okay, which item is 11.25? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 29 is 11. 31 is 11.25. So in this case, I think we have to round. I'm going to round down to 11, which means the 11th number is 29. So 29 represents the 75th percentile. This could be wrong. Okay, it wasn't wrong. Okay, I wasn't sure if you had to forcibly round up each time, but I guess that ended up being the right thing. So here, let's talk about the steps again. It was write the numbers in order, find 30 and 75% of how many numbers there are. That tells you which term you need to go to. But if it's a decimal, you're going to have to round, just round like you normally would, and then whatever term that is. So in this case, I needed to do, I'm going to circle this. This needed number 5 because that's what it was. So 1, 2, 3, 4, 5. 21 was term number 5, and therefore it's the 30th percentile. That means the number 21 is higher than 30% of the other numbers on this list. And over here, the 11th term was 29, which means 29 is a larger number than 75% of the items on this list. So whenever you're like in school or whatever and they give you a percentile of your rank, like let's say you're ranked in the 80th percentile, that means your grades are better than 80% of the other grades in the class. The higher the percentile, the better. That's why the 99th percentile is a good, because that means that's like the highest you can get. Nobody really gets the 100th percentile because you can't be better than 100% of the other people because technically you count as some of the percent. So when they say you're the 99th percentile, that means you're like the top performer. So when you're like a sports person in the 99th percentile, that means they're better than all the other people doing that sport or whatever. All right, let's do another one. Let's try and make the process better. Now, I think the hardest part of the process, honestly, or the most like annoying part, was putting these numbers in order. I don't think Desmos has a function that can put numbers in order. So if you look down here, let's see, we have total, length, mean, median, min, max, quartile, quantile, no. Sorry, none of these will give you, a reorganization in order, at least to my knowledge. Now, you might be able to Google something like number order or something like that. Yeah, there you go. See, online number sorter. Oh man, I'm risky business putting stuff in Googling. Can I select all these? Oh yeah, perfect. Can I copy that and paste it? Ah, darn. Can I copy and paste this? Does it work? Oh, I have to separate them with a comma. Okay. So, I mean, there's probably a way you could do it. I'm going to try it this way. I mean, I still think, even though I'm kind of messing with this is going to turn out better than me doing it by hand. It's a little bit faster. Okay, let's try that again. Ah, hey, I'm using ad blocker. No, not now. There you go. Here's the sorted list. There, look at that. Okay, so sort them yourself, okay? If you sort them yourself, I strongly encourage you to do what I did and write it down and then cross off them as you use them, because that's the biggest thing people mess on when they're sorting it. They forget a number exists. Or find an application like I did. That's fine. I'm not going to stop you from doing that. I don't think sorting numbers is that hard of a task for a high school student. All right, we got a sorted number list. Now, what we need to do is this, the 40th percentile, which means 40%, 0.40 times 17. That's 6.8, which rounds to 7. So on my list, I'm going to find the 7th item. So 1, 2, 3, 4, 5, 6, 7. 15 is item number 7, so I'm going to say 15. Now for the 75th percentile, 0.75 times 17, that's 12.75. That rounds to 13, so I need to find the 13th number. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 32 was the 13th number. So this is distance traveled to the workplace by a certain hospital. So if you're an employee that drives 15 miles to get to work, you're driving an amount of miles that is more than 40% of the other people that are driving to work. 40% of the people driving to work drive less than 15 miles, technically speaking. And if you're a person that drives 32 miles, then 75% of the people drive less than you, which is gross. 32 miles is a massive drive to work. What's even more gross is that 25% of the people drive apparently more than 32 miles to get to work. Look at that, we got it right. So again, the steps are, take the list, put it in order from least to greatest, okay? Find a tool or something, that's what I did here. And then the second part is you take the percentage of the amount of people you have. In this case was 17, so 40% is 17. 75% is 17, and find that item on the list. That's not the answer. 6.8 was not the answer. I need to find which item was the 7th thing on the list. Okay. Words. I feel like those will be the two hard ones of the assignment. Okay, here's more about percentiles, but you don't have to solve it. You have to consider a situation. So let's read the problem. Last year, over 10,000 students took an entrance exam to a state university. Kayla's score was the 69th percentile. Greg's score was the 58th percentile. Now, without even looking at the words, and this might be the answer, Kayla in the 69th percentile means she scored better than 69% of the other people taking the test, and Greg scored better than 58% of the people taking the test, which is good. That doesn't mean they got a 69% or 58% necessarily. Maybe they got a 30%, and everybody just did so bad that they did better than 70%, almost 70% of the people, huh? So, like when it says you're a certain percentile, that doesn't mean that was your score. If you in real life, if you're the 50th percentile, that means you hit right in the middle. You did exactly worse than half the people and exactly better than half the people, which I would say is like an average score, even if your score wasn't average. What if you did really good, but still 50% of the people did better than you? Right? That could happen. Let's say you were in the class and you get a 90, but half the class got over a 90. Well, you're the 50th percentile, but you still got a 90. All right, which of the following must be true about Kayla's score? Kayla scored lower than 69% of the people. No, that is not what 69th percentile. She got 69% of the questions correct? No, that is not what 69 percentile means. She scored higher than about 69% of the other students. Yes, that is exactly what 69th percentile means. She did not get 69% of the questions wrong. Which of the following must be true about Kayla and Greg's scores? So they're talking about both people's scores. Greg scored higher than Kayla. Well, if Greg's a lower percentile, that means he definitely couldn't have scored higher than her. So that's false. Both Kayla and Greg scored higher than the median. That could be true. We'll come back to that. Kayla answered 11 more questions correctly than Greg. No, just because she's 11 percentiles higher doesn't mean she got 11 more questions right. There could be any number of questions that would change a percentage like that. Were their scores both in the bottom half of all scores? No, that would have to be both under 50, right? So therefore, going backwards, the only answer that could have worked is this one. Both Kayla and Greg scored higher than the median. Yes. When it comes to the median is always the 50th percentile. Like if you find the median of something, you're finding the 50th percentile, which is like the halfway point. They just have a not as fancy way of saying it. They just say the median. There you go. So your question will have two parts to it, and you have to kind of consider percentiles and think about what they mean. Again, 80 percentile doesn't mean they got 80% right. It doesn't mean that they missed 20% or something like that. That just means they did better than 80% of the people doing the same thing. Or maybe it's a home value. Maybe your home is more valuable than 80% of the other homes that were assessed or something like that. They got all kinds of different scenarios where percentile applies. Funny thing about this statistic stuff is, people always say, when are we going to use this? Out of all the chapters in the book, this is definitely probably the most usable thing. Or like the concept of percentiles is very usable. Here, let's review real quick just to remember what we did. It's been a little bit of a long video, but it's the only video of the week, so it's okay. So the first 4 problems we're finding the mean and the median, and we did that by just typing the functions into Desmos, the mean and median function, and then typed in the numbers and out spits the answers. Just make sure you round to the nearest tenth, okay? On 5 and 6, we did the mode. Desmos doesn't have a mode button, to my knowledge, so we had to just figure out what number appeared the most often. And if there were numbers tied for the most often, like on this problem, 1, 2, and 4 all appeared an equally high amount of times, so they all were the mode. Then we had a few problems asking when should you use the mean, median, and mode. Remember, the median is used when you have an outlier like 96 being significantly different from the other numbers. The mean is used for pretty normal numbers, and the mode is when you want to find the most common thing. Then we found a percentage problem, like what percentage of the numbers here are less than 40. Kind of an introduction to the percentile thing. This is just saying what percent of the numbers are less than 40? 20%. Therefore, the number 40 is the 20th percentile because 20% of the numbers are less than 40. Ooh, look at that. Connecting it all together. Oh, yeah, baby. All right, anyways, then we found some percentiles. I don't want to explain the process. It wasn't too bad, but just too much. I don't want to say it again. And one problem, talking about what percentiles mean in like a context. All right, there you go. That was the assignment. Hope this helped, and I will see you on the next video. And bye.